Movement. Movement is a core part of any game. It sets the tone for gameplay and shapes the player's experience. There are so many ways to design movement, each creating a unique feel. Since we cannot cover them all in one video, I'm starting a new series, 2D Game Movement Basics. And as you already guessed, it will cover the basic types of movement. Here's what we'll explore in the series. First, grid-based movement. Think Pac-Man, Candy Crush, or any chess game. Then the free movement within a grid, found in games like Vampire Survivors or The Legend of Zelda: A Link to the Past. And pathfinding movement, used in Don't Starve or a colony simulator named RimWorld. And in this specific video, we'll start with free movement and show how to transform it into a grid-based system. By the end of this series, you'll have all the necessary skills to build movement mechanics for your 2D games. And while I'm using React, the concepts are applicable to any framework. To get started, please clone the starter project using the link in the description, and let's dive in. Alright, so after cloning the GitHub repo, you'll see the two folders that I created, Starter and Completed. I recommend you to use Starter, and at the end of the video you can just compare. I made it this way so you can play around with the code as well, and that way this tutorial will be a bit more interactive. And after npm install and npm run dev, let's take a look what we have here. And here we have this basic configuration with a hero represented as a sprite and a tile map as a sprite. As you can see, I use the arrow keys but nothing's happening, and it should be like this. Getting back to the code, let's quickly take a look what we're working with. So in the starter folder, I made it already in this way that you don't have to worry about anything except the topic. Also, you don't have to worry about the resizing. Yeah, so those are just generic hooks that will fit like 99% of the project, so you just can use it. Feel free to copy those into any of your setups. And as you can see, the scale is passed to the container, the main wrapper, and the width and height are passed to the stage. Also, go ahead and take a look at the map and what else we have here. Yeah, please take a look at the main character's component. Now we're using hero free, and that would mean free movement. When observing the grid-based movement, we will just import the other one, hero grid. At this stage, the code is exactly the same, but we just have one sprite there. Another thing I would say, this is super important, is the controls. I'm using the classic control system that returns two types of inputs. This hook is fully reusable, so don't hesitate to copy that to any of your projects. It's using basic handler to make this possible. But the actual logic is super simple. It's returning either current key or the pressed keys, which are represented as an array. And I think that's pretty much it when it comes to the basic setup. I think it's time to start implementing the movement. But in order to implement the free movement, we need to understand what's happening. So that's the theory. We have our basic character represented as a triangle that moves on X and Y axis, and when taking a closer look what's happening, we just see the directions and we see the change of the position based on those directions. That's essentially it when it comes to the free movement. So getting back to the code, let's start from getting the current direction by using the hook. Use controls And then we just get what actually comes from the hook. Get controls direction. Now let's create the position state with the use state hook. So we just use state and just put the coordinates, simple object with X and Y. Now what we need to do is we need to start writing our logic in the game loop by using the useTick hook from the React PIXI. And what we have to do here is just to get the current key so that we can check on each frame whether it's pressed or not. So let's take the current key. Then let's use the setPosition function's callback to write the logic of incrementing the current position. We have the previous value of the position here, of course. So let's define the X and Y. Now let's create our temporary variables. It's better to create those as dx and dy. Those will represent the difference on each axis. And here we just check the current key if it's actually up, then we decrement the y. Alright, minus equals 1. The same goes for each direction. Alright, here we just check the keys and we just match the direction based on the coordinate system. As simple as that. Now here comes the magic. Because we used our difference dx and dy, we just have to make a generic return here. And we need to make this x plus dx, y plus dy. And the last thing is just to use the position. Later you'll understand why we use those dx and dy variables and not just a simple increment. But now let's check out what we have got. And as you can see, we have our movement based on the direction keys. As you can see, I'm using the arrow keys and the character is moving. Okay, we have our movement based on the direction, but what I want to introduce now is the diagonal movement. And it will be done super easy because we already have a hook that returns multiple keys when they're pressed at the same time. So we get those pressed keys, actually the array of those pressed keys, and we check if the array actually includes the specific direction. That's the technique commonly used in game development. So here let's speed up a bit. I think you already understood the logic behind this. Now, important thing. As you can see in the setup with generic return, we didn't change that much. However, we already kind of implemented the diagonal movement, changing only the logic of checking the pressed keys. Now I think it's time to check out what we have. Okay, it seems that the diagonal movement works. However, there's a catch. As you can see, when I'm moving diagonally, the speed is much higher than normal. So that's the bug we have to fix, and it's a really common bug in game development. So in order to understand what's happening, take a look at this example. Let's say the left graph represents the change on both axes, and the right one is just a single axis change. As you can see, when we start moving, the acceleration is much higher on the left side. It's because the length isn't equal to 1 there, but the square root of 2, which is derived from the triangle formula in basic math. Now using this formula we can fix our bug, so let's create the variable that represents the strength of our vector. It's called magnitude. So let's just go ahead and create this magnitude thingy. And here we just make use of the formula. As you can see, dx and dy as well in the power of 2. There we go. I will write here that it's called normalizing. And to actually normalize, what we have to do is we have to divide by the magnitude. As you can see, both dx and dy. You would think that we're done at this point, but let's take a look what we have right now. Our hero isn't rendered at all, but the problem is super easy to solve actually, because we didn't check for a simple condition. When we do not change the position, the change is 0. But we cannot divide by 0, because otherwise we would get not a number error. So what I'm doing here is just checking if it's not 0, meaning if it's more than 0. And that would actually solve the problem. Yep, and it actually did solve the common problem with diagonal movement. Now the speed is exactly the same no matter the direction we're moving with. As you can see, yep, now it seems much better. And with this being done, let's create our system for grid-based movement. But before starting, it's also good to refresh a bit of theory on this topic. Let's say we have our ultimate character, and what we need to do is just to make the same position change, but with the tile size as an increment. But there's a better approach. We make a target based on the direction, and then animating the movement towards this target. That's much better and looks just smooth. Now getting back to the code, let's just reuse the structure that we already have created and paste it to the hero grid component. And now let's speed up a bit here to make new imports and start using this component. Here we just prepare. And there we go. We're almost done here. So with this structure we can start working. Now let's put the theory into practice. We just mentioned target and moving towards the target. So we're creating the target, which is default to x0 and y0. Also let's create the isMoving property that would represent the moving behavior, and which is also default to the false in this case, because when we're not pressing any keys we are not moving. Simple as that. Now let's kind of try to reuse this logic. However, in our new setup the handling of keys would happen when we're not moving. So let's enclose everything in two cases: when we're moving and when we're not moving. So let's paste this to the else block, and it's better to use the current key. So let's just change this real quick. You already know how to do this, so I'm not trying to explain this anymore. All right. And yeah, we handle the keystrokes here, but we're not about to set the position when we're not moving. So let's grab it from here and put it here on top. We don't need the set position anymore, at least here. All right. And here let's check if there's any input on any axis. We're setting the target. And yeah, also we need to say that we're moving. And you already know how to set the target. It's basically the same as the setting the position, as we previously just did. Alright, I think that's it for this block. Now it's time to handle this target, and we need to create logic to move towards this target. And in this setup, we're going to be using the same formula as we did previously, just because it's the easiest way. So here we just set the position, and we also use the previous position, of course, to increment it. We grab the X and Y from the previous position. We have the same dx as the change representation. And it's going to be like this: target X minus X, target Y minus Y. And then the distance is going to be calculated with this formula that we just used. Okay, so we have our distance here. And we need to compare this distance to the speed, let's say some value. But the speed would be the constant value. For now, let's put it here and let's return set is moving and return the target X and target Y. So yeah, that's the sign that we just finished moving towards the target, but let's introduce the speed. The speed would be 2, let's say. But this is the case when we're not moving anymore. Now it's time to create a case when we're moving, the base case. It's good to mention that this case actually snaps to the grid, so let's call it snap. And now the base case. By using this formula, we will actually set the beat for the movement. Okay, and here what we need to do is just to return the change of the movement. It's going to be basic, as we already did before a couple of times. All right, let's check out, and I can see that the movement works, but there's definitely something wrong about the movement, because the tiles are much bigger than the couple of pixels movement that I currently have. So let's actually fix it, because I think that something is wrong. But at the first glance, seems like everything's okay. We have the target, so let's go from the target. We set the target by the increment. Okay, yeah, the increment should not be equal to 1. It's actually the tile size. So that one thingy should fix everything here. Okay. So let's take a look, and of course, as you can see, movement based on grid size. Everything's working. The target direction is set when we press a key. The continuous press is setting the target over and over again, and we're moving. So here's the task for you. Try to make the diagonal movement work in here, because right now we don't have it. That should be a task. That's a serious one. I'm not kidding. So let's get back to the code so I can give you a hint. And let's also make some kind of an overview on what we did. And yeah, as you can see, when implementing the diagonal movement, the only thing that would change is the key handling. That's it. That's actually the beauty of this setup. And using this setup, we created 2 types of movement, so you can play around with that using any framework, I suppose. The next video would be about the click-to-go movement. We're going to be using PIXI as well as React, so please stay tuned. And yeah, thank you all for watching, and see you around.